Hello ladies and gentlemen, this is the tutorial for Lesson 6. Let's begin. Here's the learning targets for Lesson 6. So I can list the numbers, I can list the factors of a number is the first learning target. The second learning target is I can identify the greatest common factor, GCF, of two numbers. And the third learning target is I can test for divisibility using divisibility rules. So let's begin here. The first one, I can list the factors of a number. So first of all, we need to know what a factor is. A factor is a number that can be multiplied evenly to a larger number. A number that can multiply evenly to a larger number. Let's do a few examples here to see what that means. A number that can multiply evenly to a larger number. For example, with the number 8, the factors of 8 are 1, 2, 4, and 8. Because any of those numbers I can multiply by another number to get to 8. Let's try 16. For the number 16, the factors would be 1, because 1 times 16, 2, because 2 times 8, 3 will not work, 3 does not go evenly into 16, 4 will work, 4 times 4, 5 does not go evenly into 16, 6 does not go evenly into 16, 7 does not go evenly into 16, 8 does go evenly into 16, 9, 10, 11, 12, 13, 14, 15 do all not go into 16 evenly. However, the number 16 does. So those are all the factors of 16. We'll try one more example here using the number 24. And I'm going to use this thing that's called a factor tree. And this is a really easy way to get to all of the factors of a number. You'll really make sure that you have all of the factors. So here's a factor tree. You're going to make a branch to the left, always starting with the number 1. Because we know that 1 times the number itself will equal that number. So here we go. On the right side, I'm going to write 24. So I know 1 times 24 equals 24. 1 and 24 are both factors of 24, and now I got both of them. And so now I just keep increasing by 1. The next highest number is 2. I know 2 will go evenly into 24 because that's an even number. And this is going to be 2 times 12. And I just keep going here. The next highest number is 3. I know 3 times 8 will get me to 12. 4 will also go evenly into 24. That's 4 times 6. And if I'm doing this correct, where I'm putting the lower number on the left branch and the higher number on the right branch, I'll be left eventually in the middle here with just a few numbers. And that number is number 5 in this case. And I know 5 does not go evenly into 24. And I've accounted for all of the factors of 24 by doing this left side, right side factor. Left side, right side, left side, right side. So those are all the factors of 24. Let's try example 1 in your book. It says to list the whole numbers that are factors of 12. So here we're going to make a factor tree. We have 1 times 12. We have 2 times 6. And we have 3 times 4. Again, we just started counting up by ones on the left side here. So we went 1, 2, 3. Found all the factors that associated with that to get to 12. That was 12, 6, and 4. And now we're left in the middle here. There's no whole numbers in between 3 and 4. So we know we've gotten all of the factors of 12. So the factors of the whole numbers, factors of 12, are 1, 2, 3, 4, 6, and 12. Alright, looking at our next example here, listing the factors of 51. We're going to make a factor tree. We have 1 times 51. That's always going to work. 1 times the number itself. Then we start counting up. 2. Well, 2 will not work here because 51 is an odd number. So 2 is not going to work. 3, we take a look at 3. If you don't know, you might have to add it up. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, I'm sorry, 45, 48, 51. Oh, yes, so 3 does go evenly into 51. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I know this is 12 times, 13, 14, 15, 16, 17 times. So 3 times 17 gets me to 51. And as it turns out, those are the only multiples of 51. So the whole number multiples of 51 are 1, 3, 17, and 51. Alright, so that was the learning target. I can list the factors of a number. We're now going to move on to our next learning target, which is I can identify the greatest common factor, GCF, of two numbers. So we're just going to be given two numbers now, say the number 8 and the number 20. We're going to make a factor tree for both, and then we're going to see which factor they have in common that is the greatest. So here we go. I'm going to make a factor tree for 8. I know 1 times 8 is always going to work. 2 times 4 will work. And I'm left with the number 3 in the middle here. That's the only number in between 2 and 4. And I know 3 does not go evenly into 8. So those are all the factors of 8. Here for 20, 1 times 20, making my factor tree. 2 times 10. 3 will not go evenly, but I know 4 times 5 equals 20. So now I'm going to circle all of the factors they have in common. They both share a 1. They both have a 2 in common. And they both have a 4 in common. Now if we're going to find the greatest common factor between 8 and 20, here we find that 4 is the greatest common factor between 8 and 20. So let's try an example from the book here. Example number 3, find the greatest common factor of 18 and 30. So here we go, we're going to make a factor tree for 18. That's 1 times 18, 2 times 9, 3 times 6, 4 does not work, 5 does not work, so I've accounted for all of the numbers in between here. So now I'm going to make a factor tree for 30. I know 1 times 30. Let's see, 2 times 15. 3 times 10. 4 does not go evenly into 30. 5 does go evenly into 30. That's 5 times 6. And there's no whole numbers in between 5 and 6, so I've accounted for all of the factors of 30. So let's take a look here. Which ones do they have in common? They both share a 1. They both share a 2. They both have a 3 in common. They both have a 6 in common. And so if we're going to find the GCF of 18 and 30, here we would find that 6 is that greatest common factor. Okay, so this was the learning target. I can identify the greatest common factor, GCF, of two numbers. Let's move on to our third learning target for today, which is I can test for divisibility using divisibility rules. Divisibility, as you may have already figured out, is very similar to these factors here. So when we're talking about divisibility, we're thinking, what numbers will divide a given number evenly? What numbers will divide a given number evenly? So for example, I could look at the number 15. I know that 3 will go evenly into 15. I know that 5 will go evenly into 15. I know that 15 will go evenly into 15. And even the number 1 will go evenly into 15. So I could do 15 divided by 3, which is 5. 15 divided by 5, if I was to divide all these, 15 divided by 5, which is 3. 15 divided by 15, which is 1. And 15 divided by 1, which is 15. So we see that factors and divisibility are very closely related. You might almost say they're opposites of each other. So let's take a look at the rules for divisibility. These are in your book. Go ahead and take a minute to get these jotted down into your notes, and then we'll talk about those. Go ahead and pause the video. Alright, so these divisibility rules, for the number 2, we know some of these already. For example, for the number 10, we know that if the last digit is 0, 10 is going to go evenly into that number. That's something we've been working with probably for a few years now. We know the rules for 5. If the number ends in a 0 or a 5, the last digit in the number is a 0 or a 5, we know that it's going to divide evenly. So once we start getting in, there's one more here. Let's look at the number 2. The number 2 we know will work if the last digit is even. So let's just use the number 104. Let's use 105 for an example here. So we know that 10 will not go evenly into 105 because it does not end in a 0. We know 5 will go evenly into 105 because it ends in a 5 or a 0. This will not go. 2 will not divide evenly into 105 because this is an odd number. Let's keep going. Let's look at some of these other rules really quick. If 3 will work if the sum of the digits can be divided by 3. So in this example, 5 plus 1, that's the digits of 105. 5 plus 1 is 6. 6 we know is divisible by 3. So therefore 105 in this case would be divisible by 3 as well. Let's look at the rule here for 4. The rule for 4 says that if the last two digits can be divided by 4. In this case, the last two digits in 105 are 0, 5, so 5. And 5 divided by 4 is not an even number. It's not a whole number. So this will not divide evenly by 4. Again, we just look at those last two digits for 4. 5 we already talked about. 6 has a really neat rule. 6, if the numbers can be divided by 2 and by 3, then 6 will work as well. For the number 105, we saw that 2 did not work because this was an odd number. We saw that 3 did work, but because 2 didn't work, 6 will not work and be a divisor of 105. 7 is not one that we have a trick for, so 7 is one you just have to divide for. So you do 105 divided by 7. 7 goes into 10 one time, that's 7. Subtract, we get 35. 7 goes into 35 5 times. 7 times 5 is 35, so 7 times 15 is 105. So 7 does go into 105 evenly 15 times, so 7 would work. But again, there's no real trick for it, you just have to do the division. 8 has a neat rule. 8s are if the last 3 digits can be divided by 8. In this case, we only have 3 digits, so we take 105, try to divide that by 8. I'll do that up here at the top. 8 goes into 10 one time. 8 times 1 is 8. Subtract, we get a 2 and bring down our 5 for 25. 8 does not go evenly into 25. It goes in 3 times, but it's going to leave some kind of a remainder. And because it leaves a remainder, it does not go in all the way evenly, so therefore 105, 8 is not a divisor of 105. But again, we could see by just dividing the last 3 digits. So if we had a really large number, like 20,106, we could just look at those last 3 digits and divide them by 8 to see if it works. For 9 has a neat rule. 9 is if the sum of the digits can be divided by 9. So this is similar to the 3 rule, except for we're dividing by 9 now. So we add up the digits in 105. 5 plus 1 plus 0 is 6. If we do 6 divided by 9, it will not be a whole number. So 9 is not a divisor of 105 because it does not divide evenly by the sum of those digits. So these are the rules. A couple more down here. If a number ends in 1 0, it's divisible by 2. If a number ends in 2 zeros, it's divisible by 2 and 4. And if a number has 3 zeros, it's divisible by 2, 4, and 8. So try your best to make sure you try to memorize these rules. And let's try an example here. Example 4. Which whole numbers from 1 to 10 are divisors of 9,060? So we start going through our list here. We know that 1 will be a single-digit divisor of 9,060 because any number divided by 1 is that number itself. So 1 is almost always going to work for a whole number. In fact, 1 will always work for a whole number. We know 2 will work here because looking at my rules there, 2 is if the last digit is even. 0 is an even number. so 2 will work. We look at the number 3. So if the sum of the digits can be divided by 3, well, 9 plus 6 is 15, and I know 15 divided by 3 is 5, so 3 does go evenly into 15, so 3 will be a divisor of 9,060. The number 4, I look at the last 2 digits, and I just need to do some division here. I divide 60 divided by 4, and if this works, then 4 will go evenly into 9,060. 4 goes into 6 one time. 4 times 1 is 4. Subtract, I get a 2. Bring down my 0. 4 goes into 25 times. 4 times 5 is 20. So I have no more remainders. 4 goes evenly into 60 15 times. So 4 is also a single-digit divisor of 9,060. I know 5 is going to work because it ends in a 0 or a 5. So that one's kind of simple. Looking at the rules for 6, the rule for 6 says if the number can be divided by 2 and 3, then 6 will also work. Well, 2 worked, 3 worked, so 6 will work as well. It's really that simple for 6s. For 7s, I just need to do the division here. So I do 9,060 divided by 7. 7 goes into 9 one time. 7 times 1 is 7. I subtract, I get a 2. Bring down my 0. 7 goes into 22 times. That's 14. Subtract, I get a 6. Bring down my next 6 here. 7 goes into 66 9 times. 7 times 9 is 63. When I subtract, I get a 3. Bring down my 0. And 7 does not go evenly into 30. It does go in 4 times, but I'm going to be left with a remainder as well, a remainder of 2. So because I have that remainder, 7 will not go evenly into 9,060. So 7 is not a single-digit divisor. I look at the number 8. If the last 3 digits can be divided by 8. Well, the last 3 digits here are 060, so that's just 60. So if I do 60 divided by 8, let's see here, 8 goes into 60 5 times? No, it goes in more than that. It goes in 7 times for 56. But it does not go evenly into 60. It leaves a remainder of 4. So because it leaves a remainder of 4, 8 is not a single-digit divisor of 60, so therefore it's not a single-digit divisor of 9,060. So 8 does not work. We look at 9s though. If the sum of the digits can be divided by 9, so we add up 9 plus 6 is 15. 15 divided by 9, no, 9 does not go evenly into 15, so 9 is not a single-digit divisor. The number 10, well, this number 9,060 ends in a 0, so we know 10 will go evenly into this number. So this is how we might walk through finding testing for divisibility using these divisibility rules. This was lesson 6 practice set. I'm sorry, this was lesson 6 tutorial. We had those 3 learning targets. I can list the factors of a number. I can identify the greatest common factor of 2 numbers. And I can test for divisibility using divisibility rules. Please rewatch the video, maybe read the book if you need to. Ask me questions if you have them. We'll see you in class. Bye-bye.